Hi, this is Yusuf, and I'm going to be doing the linear regression portion of the project. So I'm going to get right into it. And the first thing we do is I'm going to add any packages that are not already installed. Now, most of these we use in class, so I didn't worry about it, but something like OpenPixel, I wrote a little script to install that. So after we have the packages, we're going to read the CSV file, which is called train.csv. And we're going to store that into a data frame, and I just displayed the first few entries to that data frame. And now we're going to start the pre-processing. So first I check what percentage of each category of each feature is missing, and I'm going to display that over here. And so we can see there's a few values which are really bad in terms of like how many missing values there are, and I'm counting anything that's not applicable as a missing feature, as a missing piece of data. So after this I take everything and I see whichever one has more than 10% missing, and this can be changed to 25%, 30%, 40%, and I pretty much add the names to an array called drops and drop everything from the data frame. And so these are all the features that are going to be taken off the data during this stage of pre-processing, and I re-showed the head of the data without these, as much as Jupyter Notebook can show. After that, I'm going to read the Excel file for the sample submission to actually obtain the price information. Right now, the data previously given doesn't have price data, so I'm going to take that and attach it to the data as actual sale price as the name, and we can see at the end now we have actual sale price. And there are still a few more things I need to do, and it's actually to take any variable that's categorized by strings and turn it into some numerical form of data. So what I do is make a dictionary, a nested dictionary, so that I can actually store all the feature names, as well as what each feature can be, and map it to a numerical value. What I do is sort everything by price first, and there's better ways to do this, such as taking the average and seeing which ones are farthest from the average and sorting them first if they're less than and last if they're greater than, attempting to get a more linear form of data. But what I did was sorted the data frame based on price, and then in the dictionary for each feature I allowed it such that the first instance of anything is what's most predominant. So after sorting it, the lowest priced house had a C all in MS zoning. So that's the first thing here, and it's going to be mapped to 0. And the last thing that showed up was FV, and that got mapped to 4. So I do that for every feature and displayed it. I again display the head of the information just for reference. And this section of code checks for every column if its data type is an integer or float. It doesn't do anything except check which values are missing and replaces it with 0. A better way to do this, and something I'm planning to do, is replace it with the average. And for anything that's not an integer, it'll actually look up the value from the dictionary I previously showed and replace that value. Now the trading data, it's going to be the same as the data frame, except I'm going to remove the ID and the actual sale price because we don't need that for the training data. I'm going to move the actual sale price to target, and then I'm going to begin the linear regression. I'm going to set the linear regression classifier to this LReg class, and I'm going to partition it through train test split into train 1, test 1, train 2, and test 2. And then I'm going to fit the data, and I'm going to call the linear regression. Okay, so over here I pretty much just have a variable called res and array. Res is a 2-dimensional array, and array is single dimensional. second. And so this is where I actually run the data, sorry, and I get the values over here. I go through all of it and then add the differences between the target, which is the actual price, and what I calculated in this array A. After that, I do the root mean standard error, and so I square it by multiplying it by itself, add it to the sum, and divide by data length. Afterwards, I square root everything, and I get a final RMSE of 31,711 with an accuracy of 83%.